Alrighty, Earth Science, let's do it. We're going to start talking about some revolution stuff and how that affects um, our seasons and our life on Earth. We're going to quickly recap some motion of the sun stuff from last week and kind of use that as a bridge into this next week's worth of stuff. So, a handful of questions to talk about the apparent motion of the sun. So, first, is the sun at the same height in the sky every day? Now, hopefully, you remember this from our um, apparent motion of the sun lab that we've been doing all year long with the popsicle sticks and going outside and tracing the shadow of the sun and measuring it. That the sun is not the same height in the sky every day. It actually is greatly affected by what time of year it is and where we are in location to the sun, and we'll talk about that a little bit more. It is the highest in the sky during which season? The summer is when we have the highest altitude of the sun, and it's also when the sun is out for the longest. And the lowest is, of course, winter. Does the sun always rise in the exact same spot? Now, we've talked about this where the sun rises in the east and sets in the west, but it does not always rise in the exact same spot. It varies a little bit. Specifically, when the sun is in the northern hemisphere and it rises, it is north of east. And so if you were to look directly east, the sun in the summer will rise a little bit north of that due east. In the winter, it's going to rise a little bit south of due east. So in the summer, it rises a little bit north of due east, and in the winter, it rises a little bit south of due east. And in the fall and the spring, well, you guessed it, it's directly east. And so it kind of varies where it's rising and setting throughout the entire year. Is the sun out the same amount of time each day? Absolutely not. The sun is out for many different periods of time throughout the year. It is certainly out for longer during the summer than it is for the winter. Is the summer in New York State is about 15 hours worth of daylight, and in the winter, New York State has about 9 hours of daylight. And obviously, we'll talk about this a little bit. And so, the reason why is because the Earth is tilted on its axis, and that affects how much sun and how long the sun is out for in both the summer and the winter seasons. Okay, so we're going to have a little celestial sphere on the next slide, and what we're going to be putting on that celestial sphere is, well, we're going to start with the summer solstice, the winter solstice, and then the fall and the spring equinox. Summer solstice is the start of summer, June 21st. It is the longest day of the year, and it is when we have the most amount of daylight. Winter solstice is December 21st. It is the shortest day of the year, or the day that we have the least amount of daylight. Start of winter. And then the fall equinox and the spring equinox are the start of fall and spring, and they have equal amounts of daylight and sunlight, or daylight and nighttime, which is why they're called equinox. They have equal amounts of daylight and night. So the zenith is the spot in our sky directly above us, the point directly above us in the sky. The horizon, hopefully you know, is where the sky meets the ground all the way around you. And then the sunrise, sunset, and noon on the summer solstice path. Okay, we are going to get into this celestial sphere. Now, the celestial sphere, like we just talked about, if this is north, this is south, then that means this has to be east. This has to be west, north, east, south, west, which means all three of these are sunrises. These are paths of the sun. And so the sunrise is here, and then it goes and sun sets over here. Sunrise into sunset. Now, think about this. Which one of these paths is the longest? Well, it's definitely this one. And what does that mean? Well, this one is probably the start of summer. It is the longest path, which means the sun is in the sky longer, which means this right here is actually our summer solstice. This is 6/21 summer. Where this would be our winter solstice, 12/21 and it's winter. And this would be our fall and our spring solstice, or our fall and our spring equinox, I'm sorry. This right here is our zenith. Directly above us. Alrighty. And kind of, it goes through that, all that. It's a little bit cleaner. It's not Mr. P's mouse handwriting. We have our noons here, which I forgot to add in, but our noon is our highest point in the sky, zenith, and these are our paths of the sun. Cool. Last but not least that we're going to talk about is this. It is the reason why the seasons happen. We're actually going to talk about it just without any notes, but just me explaining it out. And so you'll notice that the Earth here, we're talking about revolution. So the Earth is going through revolution, the revolution of the Earth on the sun. And so it's going around the sun. And we have, I'm going to draw in our equator in each of these little globes with a red line. So you will notice that the Earth is tilted on its axis all the way throughout these paths. And there are certain times where the Earth's path, and I'm going to speak as somebody from the northern hemisphere, there are times when the Earth is tilted towards the sun, and there are times where for us the Earth is tilted away from the sun. Times where we're kind of leaning into the sun, and times where we are quote-unquote leaning out away from the sun. Specifically, if I'm a person in the northern hemisphere, which we are, the sun would be leaning in, or sorry, the Earth would be leaning into the sun in this point right here, where we are leaning kind of inwards towards the sun. Now notice that this point is when we are furthest away from the sun. This distance is greater than this one. And so this is where we are furthest away, but we are leaning in. And the reason why this is important, and let me erase this one little line. Actually, we'll erase both of them. Whoops. Is because when the sun gives off its sunlight, it's coming in here, and the northern hemisphere in this section, in this part right here, is more direct sunlight. It's getting more direct sunlight than the southern hemisphere. And so because we are leaned into the sun and we are getting more direct rays of sunlight, this is going to be where we are experiencing summer. Despite the fact that I just said that this is where we are furthest away from the sun, we still have summer, which is the biggest misconception. We do not have summer when we are closest to the sun, and we do not have winter when we are furthest away. The reason why we get summer and winter in our seasons is because of the Earth's tilt. The Earth's axis, 23.5 degrees, is the reason why we have these seasons, because there are times in the year when we are leaned, quote unquote, leaned into the sun and receiving more direct sunlight, and there are times when we are leaned away from the sun and getting less direct sunlight. In this case, the southern hemisphere is getting more of the sunlight, more direct rays, which means that we are in winter. And yes, that's right, when we are in winter, this is the reason why the southern hemisphere is in summer. And when we are in summer, that's when the southern hemisphere is in winter. This is why you see things like professional snowboarders and the like, people whose profession is needed for one season, right? They go into the southern hemisphere when we are experiencing summer to still be able to do their job and to stay in places where it's snowy the whole time. And so let's think about this. If the Earth's revolution is this way, counterclockwise around the sun, and this is our summer and this is our winter, well, what's this season right here? Well, if it's summer and then in between winter, well, what's in between summer and winter? This would be the fall. And in between winter and summer, this would be our spring. So right now, we are experiencing right around this stage. We're probably right around here, close to here, maybe even closer to here in our actual yearly, because this, remember, is the summer solstice, 6/21. And so we're approaching this right now in our current loop around the sun. So we're going to go into this a little bit more next week, and your questions are going to be on this next or at the end of this week. But that's where we're going to stop, and we will continue on next week. See you guys.